Section 4.3, Properties of Logarithms. The first property that we're going to talk about is the product rule. Let B, capital M and capital N, be positive numbers where B cannot equal to 1. Log base B of M times N. Notice these are multiplied together. That's the reason why we have the product rule. When you have logarithm in the form of log base B M times N, it equals to, you separate them apart, log base B of this first letter M plus log base B of N. So to use the product rule, you actually separate them apart into two different logs with a plus sign in the middle. The logarithm of a product is the sum of the logarithm. Sum meaning to add. Product meaning to multiply. So the logarithm of a product is the sum of the logarithms. Alright, we use the product rule to expand logarithmic expressions. So what I first want to do is to work a problem, and let's use the product rule to expand these logarithms. We're going to work two different ones. So let's look at this first one here. Log base 4 of 7 times 5. That's a product. So according to our rule, we're going to separate them apart. So this would equal to log base 4 of 7 plus log base 4 of 5. So our product was separated out to the sum of the logarithms. That's your product rule. Let's use another product rule to expand. This is 10 times x. This is equal to log base 4 of 10 plus log base 4 of x. The product was 10 times x. We separate them apart into a sum. Okay? So after the product rule, let's talk about the quotient rule. Remember, quotient means to divide. Product means to multiply. So here we have the quotient rule. Let B and capital M and N be positive real numbers where B cannot equal to 1. Log base B of M divided by N, there's your quotient, is expanded to log base B of M, the number that's in the numerator, minus log base B of N. The logarithm of a quotient is the difference. Difference meaning to subtract. The difference of the logarithms. So anytime you have a quotient, you will separate them apart and subtract them. So let's use the quotient rule to expand each logarithmic expression. So let's look at this first one here. You see they're dividing. This is a quotient. So according to our quotient rule, we take log base 7, use the one in the numerator first, 10, minus log base 7x. Now, if we could evaluate any of these logarithms, we would, but we can't in this one. All right, let's go to B part. ln of e to the third divided by 7. Okay? ln of e to the third divided by 7. Now, we'll treat this ln just like you do the log. So let's write down ln. Now, what is my base? We learned in one of the previous videos. Ln has an understood base of e. Log has an understood base of 10. So if you don't see a log for, if you don't see a base for log, it's 10. If you don't see a base for ln, it's e. So I have ln base e of the numerator, e to the third, minus ln base e 7. Now, can we evaluate either one of these? In other words, is e raised to some power that would give me e cubed? I'm going to pull this over to the side. ln e to the third equals to what? Think about in the last video we just looked at. e raised to what power gives you e to the third? Well, wouldn't it be 3? In other words, this whole ln base e to the third equals to 3. So I'm going to replace this entire part to 3 minus ln base e of 7. So that's your answer on expanding using the quotient rule. So again, anytime you can evaluate a log or a ln, you do. Okay? And then the last rule that I want us to look at is our power rule. Let b and capital M be positive real numbers with b not equaling 1, and let p be any real number. Log base b m to the p power. What you do is you bring p to the front. It says that the logarithm of a number with any exponent is the product of the exponent and the logarithm of that number. So we put p in the front times log base b of m. Okay, so we never leave an exponent. We'll always bring p to the front. So let's look at an example here. If I have something like this, log base 5, 7 to the 4th. I have an exponent. So to expand it, we bring 4 to the front, so that's 4 times log base 5 of 7. And that's all we would do to that problem. Let's look at another one. ln of the square root of x. Now remember, we can't have radicals, so we need to change that to exponential. X is being raised to the first. We're taking the square root. Anytime you don't see a root, that's understood 2. Okay, this is base e. Let's don't forget this. So really this is ln or ln x to the 1/2 power. Remember, ln to the x to the 1/2 power. Power over root. We had to change the radical to exponential. Okay, so now we have ln or ln x to the 1/2 power. Now using the power rule, bring the exponent to the front. So my exponent is 1/2. I'll bring 1/2 to the front. So this will be 1/2 ln x. That will be my answer in that problem. 1/2 ln x. Remember, ln has an understood base e. All right, let's look at one more. We have log 4x to the 5th. In other words, both the 4 and the x are raised to the 5th power. So again, using the power rule because of the exponent, this would be 5 times log 4x. So that would be my answer there. 5 log 4x. So let's look at all 3 of these rules again. For our properties of expanding logarithmic expressions, for capital M greater than 0 and capital N greater than 0, we have our product rule first. Product meaning multiplied. When they're multiplied together, you split them apart and add. That's the sum. On the quotient rule, quotient means to divide. When they're divided, you separate them apart and subtract. Difference means to subtract. And then your power rule. Anytime you have an exponent, you bring it to the front. It would become p log base b capital M. These are your properties of logarithms.